Okay, chapter 1.4 is about rational expressions. This is where we have variables in both the numerator and the denominator. A reminder on how we can reduce any fraction. Let's say I have the fraction 14 over 21. Now, you can see that both those numbers are divisible by 7, but I'm gonna show that multiplication to make a point here. So we have 2 times 7 is 14, and 3 times 7 is 21. So the only way we can reduce a fraction is by reducing the same factor that's being multiplied in both numerator and denominator. What that means is if we have some addition, subtraction, okay, even though 3 can be divided, 3 and 6 can both be divided evenly, because 1 can't, we cannot reduce this fraction through the addition subtraction. Now I could add the 1 and the 3 and then go ahead and reduce it, but I want you to be careful about addition subtraction and reducing through that. People always want to do it that way and it doesn't work. So when we tackle problems like this and we're asked to simplify and also tell where the expression is, the values of the variable for which the expression is defined, actually I need to change that to undefined. Okay, because we do domain and range by exception, so we were going to look at where it doesn't work. All right, the way we do this is just by turning each part of the fraction into a multiplication. Now the top of this fraction, 3 times x minus 3, is already fully factored, but the denominator can be factored. And we're going to just leave this factored in the numerator, and that's the difference in 2 squares, so it's x plus 3, x minus 3. That's a good thing, because that'll allow us to reduce through the 2 common factors in numerator and denominator of x minus 3. And what we get out of that is we get 3 over x plus 3. Now, where it's undefined, so this is our final reduced expression, but when we talk about where it's undefined, look, rational expressions are always undefined by the numbers that will make the denominator turn into 0. So on x plus 3, if I have a negative 3 adding to that plus 3, that's going to be 0. I'm going to get divided by 0. That's a bad thing in math. And on the we also have to do this for the reduced factors. So we're going to do the same thing for x minus 3. If x equals positive 3, then that also turns to 0. The reason that happens is because even though we reduce those factors out, they are still places where this function doesn't work in a rational expression. Okay, on to example 2. So this is a multiplication problem, but before doing the multiplication, I don't know if you noticed, but not only do we reduce them, but we don't really multiply our reduced expressions. So I'm not actually going to do the multiplication. I'm just going to see what happens with my factoring and reducing, and then we'll write the remainder as a single fraction. So on both of these fractions, the numerator is fully factored. So first denominator, 2 numbers you multiply to get positive 1 and combine to get negative 2. That's going to be x minus 1 times x minus 1. That's a simple quadratic factoring. All right. On the right-hand side, we have an x minus 1 in the numerator, fully reduced, and then we have 2x minus 3. Okay, so when we look at the 2 fractions, and by the way, we can reduce across fractions. For example, x minus 3 in the first fraction will reduce with the x minus 3 in the denominator of the second fraction. And same with the x minus 1. And what we have remaining here is, all right, this gets a little tricky because my 2 numerators just went away. But if you think about the reducing, when you divide x minus 1 times x minus, divided by x minus 1, you get a 1. And so that's what we're going to write in the numerator. So when the numerator disappears by reducing, we just write a 1. And the remaining factors is x minus 1 and 2. I'm going to write them this order. Right. And the places where this original expression is undefined is going to be x can't be equal to positive 1 and 3. Let me see if I wrote that. Yeah, I'm going to go back and write this. X can't be equal to those two values. I'll tell you though, on the pay attention to what exactly the quiz questions are asking, because they don't always ask you for where to state where it's undefined. Sometimes they just ask you to reduce. All right, last problem, same idea, except for I have division here. So the one thing I'm going to do to start this problem is I'm going to turn that division into multiplication by flipping the second fraction. I'm just going to rewrite it all. And flip that second fraction. All right, now I'm going to start factoring, just like on the previous problem. Two numbers that will multiply to give me 6 and add or subtract to give me -5. That's going to be 2 and 3. Yep. So x minus 3, x minus 2. I was thinking at the beginning of 1 and 6, but it's easy to get those two backwards because the numbers are so close to each other. Now on the bottom, that's a little bit trickier. What I do know is I have a -2 there. Now I'm going to talk in a little bit about AC factoring, but the other way you can do it is basically just do a little bit of guess and check. So when I look at the -2 here, this is my biggest hint, and I like it because there's only two numbers that multiply to give you -2. And I'm going to guess that the 2 is negative only because I've got x minus 2 in the numerator. It would be pretty obvious if I guessed wrong, but I'm just going to guess I have a -2 here and a positive 1. Now, this 3x squared, the only way I can do that, I can get to 3x squared through multiplication of integers is by having a 3x and a 1x. So if I try 3x here and a 1x here, I've got to turn around and check my two multiplications to give me my x term. This 3x times 1 gives me a positive 3x. The -2 times x gives me a -2x. Now here's the problem. That's going to give me a positive 1x. And so that's not what I wanted. I'm going to go back and look at switching the 3x and the x. I got to rewrite it. And see if that works out any better. So that gives me a -6x, that multiplication. And this one will give me a positive 1x. And that will indeed give me my -5x. So that's my trial and error. I just look at it and see what x values I have, because I know my first two multiplications to get 3x squared and -2, I know I've already taken care of that. So let's see what we can reduce here. Got x minus 2 in the denominator and the numerator, and I think that's all the reducing I can do. So we get x minus 2. Yeah, I got a lot of x minus 2, but it leaves a lot left. Oh well. And again, I'm not going to multiply this out. I'm just going to write it as factors. There's absolutely no reason to multiply it. And where is this original expression undefined? It's going to be undefined. And I go to the multiplication statement. it's going to be undefined at x can't be equal to -1. And for this one, if I set that up, if I'm not sure where that's equal to, what x value makes that equal to 0, I'm going to set up a little equation and solve it. So it looks like on that one, x can't be a -1/3. And my last factor in the denominator, actually, that's it. Okay, and we are done with this video.